is x3 x11 dx. In this type of problems, especially when we have not secant 2x minus 1 equals to tangent 2x. So in this type of problem we should use, for example, substitution x3 equals to secant 2x, secant 2 theta, 3x 2 dx equals to integration of minus 2 sinus theta secant 3 theta d theta. If we want to calculate secant 2 theta derivation, the minus 2 sinus theta cosinus on cosinus 4 theta, which is equals to so we have this relation. Second secant 2 theta d theta. Let me write again. So x3 3x2 dx 2 tangent theta secant 2 d theta multiplied to x3 d theta 3 dx on x equals to minus 2 tangent theta d theta. Our integral was x3 minus 1 x11 under sqrt x5 dx. dx on x equals to 2 tangent theta integration of secant 2 theta minus 1 x5 x4 write to the next page. I we should write this relation. It's better to write this relation. x3 minus 1 or x12 apply to x dx dx substitution to x x3 minus 1 on x6 dx on x. We obtained this result. x3, we choose this assumption, secant 2 theta. We obtained this result, 3 dx on x minus 2 on 3 tangent theta d theta, and as a result x6 secant 4 theta. Substitution to this integral, we can obtain I secant theta x3 radical x3 minus x secant 2 minus 1 equals to tangent 2. Tangent 2 is square, tangent 2 radical cotangent 2 tangent theta secant 4 theta multiply 2 on 3 tangent theta d theta. The answer, the result is tangent 2 on secant 3 theta d theta. Cosinus 3 theta multiply sinus 2 theta on cosinus 2 theta d theta minus 2 on 3 here. So we can obtain a simplified integration. Cosinus theta sinus square theta d theta. Now sinus theta u du cosinus theta d theta. u2 du u 3 plus 1 2 plus 1 plus c. Equals to cosinus sinus theta c sinus 3 theta plus c. And secant to x3 cosinus 2 theta equals to 1 on x3. Sinus 2 theta and sinus theta substitution into this result I equals to plus c.